Hello mathematician, we see one nice problem from linear algebra which is asked in the CSIR exam. Let n be a positive integer and we define the set Hn to consist of the matrices A equal to Aij satisfying Aij equal to Ars if I plus j equal to R plus S. Okay, so the matrix A satisfying the condition that two entries are equal in the matrix A if the sum of the indices are equal. Then this Hn form a vector space that you can verify, and we want to find what is the dimension of the vector space Hn. Okay, okay, let's look at this problem. So whenever they are giving some condition on the matrix entries, so they are saying uh, when some condition is satisfied, matrix entries are equal. When they say some, when they give problem like this, you try to visualize that condition pictorially, then immediately you can find the dimension. Okay, so for example, let's see this problem. Suppose we look at a 2 by 2 matrix, then its entries are a11, a12, a21, a22. Okay, now everything in this diagonal has sum of the indices 2, but here there is only one entry. 1 plus 1 is 2, and no other entries here has sum of the indices 2. Okay, therefore this entry is this is the only entry whose sum of the indices 2. If you look at everything in this diagonal, then all this element has sum of the indices 3, and here everything sum of the indices 4. So since everything here has sum of the indices 3, from the given condition these two entries has to have the same value. Okay, therefore this entry is dependent on this entry, because whatever value you're going to put here, the same value you're going to put here also. So this is a dependent variable of this variable. So basically when you count the dimension, this is one dimension, this is dimension 2, this is dimension 3. You don't need to include this. Okay, therefore when n equal to 2, you get the dimension 3. Okay, and you can actually find a basis also which consists of three elements. So this is an independent position, so you put this position 1 0 0 0. These two positions are dependent, so we put a 1 everywhere there. So 0 1 1 0. This is again an independent position, so you get 0 0 0 1. Okay, similarly if you look at the 4 by 4, 3 by 3 case, here everything has sum of the indices 2, here everything has sum of the indices 3, here everything has sum of the indices 4, here everything has sum of the indices 5, here everything has sum of the indices 6. Okay, therefore this entry is dependent on this entry because all these places going to have the same value. Similarly these two entries a13, a22, they are dependent of a31. Okay, so these two positions are dependent on this entry. So this is a independent position, this is a independent position, this position is dependent on this position, this is a independent position, this position is dependent on this position, again this position also dependent on this position. So again this is a independent position, this position is dependent on this position, this is an independent position. So you get dimension will be 1 2 3 4 5. Again like here you can find a similarly basis. Okay, so for 2 the dimension is 3, for 3 dimension is 5. You can actually immediately generalize for n. For n you will get 2n minus 1. How do you know so for like 2 you get 3, for 3 you get 5, similarly for 4 you are getting 7. So what is this sequence? So it is basically 2n minus 1. But how to verify that for n, for arbitrary n the dimension will be 2n minus 1? Because you follow this pattern of ones, you can actually explicitly find a basis in the basis for Hn. Okay, whose cardinality will be 2n minus 1. Therefore the dimension of Hn is 2n minus 1, and therefore the option D is fourth option is correct. Okay, okay guys, if you learned something new from this video, please click the like button and share with your friends and subscribe to my channel. Thank you.